Welcome to the House of Maths and my next session on algebraic fractions. Two questions on the board here. First one, a little bit different to some of the ones we've looked at so far in that it equals something. So we've got an equation here. And the second one is a simplifying one, but we've been asked to give it in a particular form. Okay, so we need to simplify and make it look like this. So that might give us a few different challenges. Right, so let's begin with looking at this one where we're told it equals 3. Now, sometimes it might be useful if you can simplify it before you start trying to manipulate this. So I'm spotting here that we've got that difference of 2 squares. So 4 is a squared number. You could write that as 2 squared, x squared minus, and we could write that as 1 squared. So once you've spotted that you've got the difference of 2 squares, you can immediately write this as 2x plus 1, 2x minus 1. Okay, now why have I done that? Why is that useful? Well, you can see that in the denominator here we've got 2x plus 1, and we've also got 2x plus 1 here. So that'll just help us a little bit when we try to simplify. So what we're going to do is we're basically going to multiply through by 2x plus 1, and then we're going to multiply through by 2x minus 1 to clear the fraction. So by doing 2x plus 1 first, we're going to be left with just 4 here. If we multiply the top by 2x plus 1, these cancel out. I just put that in, I'm multiplying by that, so they will cancel. I'm multiplying this by 2x plus 1, so they will cancel, and I'll be left with 1 over 2x minus 1, oops, not 11. And we've got to multiply that by 2x plus 1. And then we're going to multiply through by 2x minus 1. So we're going to get, when we multiply through by 2x minus 1 here, which is going to be left with 1. Like so. So now we've cleared the fractions and we can begin simplifying this. So we know that this here is the difference of 2 squares. It's that, isn't it? It's just basically 3, 4x squared minus 1. Okay, so if I want to multiply that out, I'm just going to get 12x squared minus 4 there. I've got 1 here. If I multiply this out, I'm going to get 8x minus 4. I've put 4 there. I mean 3. And minus 4 plus 1 is obviously going to give us 3 as well. So we're going to get 8x minus 3. Like so. Notice we've got minus 3 on each side, so they will cancel out. And we're left with 8x equals 12x squared. Now you've got to be careful here. You might be tempted to think, ooh, I can just cancel out an x from both sides. And I'm going to get I'm going to get 8 equals 12x. And then I can see that x is 8 over 12 or 2 over 3. But you'd miss a solution if you did that. What I would do here is I would subtract minus 8x from both sides at this point. So you're going to get 0 equals 12x squared minus 8x. Then factorise. I'm just going to pull an x out though. And I'm going to be left with 12x minus 8. Okay, so hopefully you'll see there that x equals 0 is a solution. Okay, so x equals 0 is a solution, and the other solution is the one we've got down here. X equals 8 over 12, 2 over 3. Okay, so there are 2 solutions there. And the great thing about these sorts of questions is that I mean, we've got our two solutions here. Let's just plug them back in and see if they work, because they should. So I'm just going to create a bit of space here. And these are our solutions. So if we make x 0, we should get 4 over and that should equal 3. So, well, 4 over 1 is 4. And this is 0, so we're going to get -1. Great. So that definitely works, doesn't it? That is our solution. Then the 2/3, so we're going to get 4 over okay, so if we plug our 2/3 in where we've got x, we should get 3 as our answer. Let's try. So I'm going to 2 times 2 is 4, so that's 4 over 3 plus 1. Well, I'm going to write that as 3 over 3. Okay, so I can add these two together. So we're going to get 4 and 7 over 3, like so. So if I pull the 3 to the top, that's going to give me 12 over 7. Okay, if you're not sure what I'm doing here, I'm just changing that to I'm imagining it's 4 divided by 7 over 3, and then I'm saying 4 times 3 over 7, which is 12 over 7. That's how I'm getting that. Okay, so remember, think about your bidness here. You've got to square first, so we're going to get 4, and then we're going to get 4 over 9 minus 1. Now 4 times 4 is 16 over 9. Subtract, it's a 9 there, isn't it? So I'm going to make that 1, I'm going to call it 9 over 9, okay, which is the same thing. So I can do the subtraction easily. So that's going to give me 7 over 9. So I've got 1 over 7 over 9. So the 9 comes to the top. So that's going to be 9 over 7. And that should equal 3. So 12 plus 9 is 21 over 7, which does equal 3. So we're okay there. Those are our two solutions, and they both work. We've checked them. So remember to check your solutions if you can. When you've got an equation like this and you've got an answer, and you've worked out your x values, here, plug them back in, see if they work. Obviously, if they didn't work, we'd have to look at it again to make sure we got the right answer, but we're okay with this. Okay. So let's have a look at our second problem over here. So this divided by this, and we want to make it look like that. So a bit like some of the problems we've done on previous sessions, we're going to start by factorising these and see what will cancel out. So we can't do anything with that. Underneath, hopefully you can see we've got the difference of 2 squares. So this could be written as 3 squared, this could be written as 12 squared. So we can immediately write this as 3x plus 12, 3x minus 12. And we're dividing. Now I'm going to flip this and do a multiplication. So these need to flip upside down. So this is going to be like so. Now, I should have probably expanded this first. So if I do that, just above 3 times x is 3x minus 12, like so. Okay, so you can see we've got a 3x minus 12 on top, and a 3x minus 12 below. So I'm going to cancel those like so. And I've got 2 and 6 here. Well, 6 over 2 is 3, isn't it? So cancel that and replace it with a 3. And I've got x cubed and x to the power 4. Well, I can cancel that and just leave x down there. So let's put together what we've got here. So we've got 3 on top, and underneath we've got x, and then in brackets here 3x plus 12, like so. Okay, so we've simplified that quite a bit here, but notice it's close to this, isn't it? But it's not quite right yet. So what I'm going to do is I'm going to multiply this out. So I've got 3x squared plus 12x. Okay, and we can see that we need a 1 at the top there, and the only way we're going to get that is if we've got a 3 on top here. We need a 3 as a multiple at the bottom, so I'm going to pull 3 out as a factor at the bottom here. So I'm going to have 3 on top, and I'm going to pull 3 out as a common factor because 3 is common to both bits here, and I'm going to leave the rest. So that's going to be x squared, well, not minus, it's a plus, isn't it? And that would be 4x there, wouldn't it? Like so. Okay, now I can cancel here, and that leaves me with 1 over x squared plus 4x. Now we're still not there, are we? We still need to have a factor of x outside. Well, we can factorise again because I can see that we've got x common to both bits here. So if I just go over here, I've got 1 on top, and I'm going to pull x out as a common factor, and that's going to give me x plus 4. And now we're finally in the form that we're asked for. So 1 over x brackets x plus 4. So r is an integer, which it is, and we can say that r equals 4. Okay, so there we are. Hope you enjoyed that. If you did, remember to hit the like button. Thanks very much for watching.